Hi there, knife people. Hello, lady and gentlemen. Tonight we're going to talk about a knife that I had no clue existed 3 weeks ago. Here it is. If you recognize it, that means you're totally plugged in with everything knife related. I was not, apparently. I wanted to do this review as an inside out review. I start from the inside of the knife, basically disassemble it, show you features inside of it, and I work my way out to some tests and comparisons. And here it is, Three Rivers Manufacturing, MagnaCut Atom Lizard Skin. This is a 100% US made knife. Here it is, inside out. Let's go through that, starting with an edge, which is the most important component on the knife. This line right here, secondary bevel, edge, to recall it. This knife can cut. No problem. This is the test I do on my channel. The towel is not attached to anything, and without any tension, the knife cuts like a champ. Straight from the factory. Not oftenly seen. So let me show you with a microscope, which you see on the left, and on the right you see the screen of my iPad. Here you go, and there's our edge. Well, right off the bat, I see a little bit of a burr. It doesn't look like they stropped it at the factory, but it still cuts quite well. As you saw the paper, it was just a small amount of tearing there. But the media they used, I estimated to be between 360 and 460, somewhere in that region. Not anywhere close to mirror polish, but nice toothy edge. Flipping it over on the other side, if you take a close look near the apex, I see just a tiny bit of convexity, which tells me it is highly likely they ground this blade on a large industrial belt sander. So while the overall bevel angle is pretty low, I would estimate 15, 16 degrees, when you go to sharpen, remember that you will have to remove more material because of that convexity if you want a continuous plane toward the edge. Alternatively, you could put a micro bevel. Next, I am flipping it on its spine to show you the apex and to check symmetricity. Look at that. With the naked eye, left and right side of the apex or of the secondary bevel are symmetrical. Let's put a tape on it. Yeah, ½ inch on each side. Perfect. This is perfection. My magnification here is 50x, give or take, and an inch means it's 0.02 or 20 thousandths of an inch behind the edge thickness. So in the upper left corner, you see the actual measurement was 25 thousandths of an inch. What's the significance or importance of that? The blade is thin. The stock is 92 thousandths of an inch. So if you get more than 30, 40 thousandths of an inch behind the edge, you're sort of detrimenting its cutting performance. It's definitely designed to be a slicer. What you see here, we need to strop it. I haven't stropped it. Let's strop it. Let's see what it looks like stropped, huh? Anybody with me on that? Let's do it. Let's do it. Okay, stropping doesn't involve counting how many times you pass. It's not an accounting skill. It's a knife sharpening skill. You don't need to count how many times you're passing. You can totally fly by the seat of your pants. You know, if you don't think it's the right technique, I don't care. This is not the area that I'm open for suggestions. Not that I know it all, I found my groove. Okay, so look at this. Look at this. The pudding is in the proof. Or versa versa. Let's turn it that way. Yeah, I'm scared to cut anything now with it. We're gonna do it anyway. So here we go, unsupported paper towel. It's cheap. I think I got it at Walmart. 2 layers, which makes it harder actually. How about that? Factory edge. Just lightly strop. The blade, very thin, 92 thousandths I measured right around here, toward the back of the blade. MagnaCut, I spoke with the manufacturer, Miss Hillary, at the head office there, and she said it's supposed to be at 62 to 63 HRC. And we will test this theory using my hardness tester. Okay, liners, titanium. It's different from titanium that's used on scales. It has other alloyed metals in it, and therefore it has higher density and also is capable of providing spring tension as needed on this liner. Both liners have holes machined and tapped for screws. So if you were to order, you could specify in the order that you would like left-hand mounted clip. You can get it there. You cannot, unfortunately, get a left-hand mounted spring scale. You cannot swap them out because of this difference in the scale, which brings us to the scales. Titanium, beautifully machined. I'm going to talk about machining separately. I ran CNCs for 7 years, and when I was in the shop, which was decades ago, I don't think a machine existed that could do this level of sophistication on a piece of titanium, machining wise. To illustrate, here is the 2-axis regular CNC operated mill making titanium scales. And this technology existed since late 70s when CNC programming became available. It's pretty labor intensive, requiring multiple setups and a lot of manual operations, but a smaller upfront investment into equipment. Oh, welcome to the 21st century here. This is what a multi-axis mill or machining center can do. And I'm pretty sure the scales we're looking at today were made on a machine that is similar, maybe different in size. Sorry if I'm ruining it for you Chris Reeve lovers, but the 2-axis machine is all that's required to make scales for example, this Omnizom, and a multi-axis mill would be required to make the TRM Atom scales. And TRM is doing absolutely everything that's required to deliver a beautiful knife, but nothing that is not required. And that's how you end up with a knife that is functionally similar to Omnizom, but $300 less expensive. They didn't waste our money or their time smoothing out pieces that don't need to be smoothed out. Everything else is impeccable. Tolerances are tight. The interesting feature of this knife, the scales can be completely removed without fully disassembling the knife. So what I did, you will never have to. I just wanted to avoid the warranty right off the bat. So I'm not worried how I use the knife for the rest of its life. Anyway, but to illustrate, here's the pivot nut, and it completely goes through. So to remove the scales on one side, you would have to undo these 2 screws and 3 screws on this side because these 2 screws hold the titanium spring pocket clip to the scale. And you can see it's pretty tight. Like when it's disassembled, this is below this point, that little bend. So it's under quite a bit of tension when assembled. Interesting. In-house machined hardware here. Pivot hardware is steel. Stainless steel, not titanium. The spacers I believe to be titanium, and the rest of the screws are stainless steel and phosphate bronze washers. So my question number 1 to Hillary, when after I looked at the knife, and I specifically waited until I look internally at the knife and take some mental snapshots. Only then did I call the company. I was under impression that they hired an airspace engineer to design this because this design is optimized for everything that an airspace company would demand from a component that goes on an airplane or a helicopter or a space shuttle. But I was wrong. The design is done by Les Halpern, the owner of the company, and the gentleman in the picture is responsible for beautiful grinds, and his name is Mike Irie. This Mike Irie. And that is why the knife is nearly perfect. Optimized for weight, optimized for manufacturability, ease of disassembly, reassembly, and maintenance. The only thing that could make it lighter is punching some holes through here. They probably did not want to do it to not risk, putting a warp in the scale. Anyway, the washers are 8,000 thick washers, very, very thin. The whole system is designed to be very thin. One area of concern for me was the floating stop pin. So the bottom line is this pin doesn't set the exact distance between the two scales. So when you're tightening the pivot, which goes through this side, come on, very, very tightly taut. It goes through this side, and then it's captive here. And as you can see, that captive feature, that flat face, is not going all the way down along the whole pivot. And my hope was that that's what's going to set the space between the two scales. Unfortunately, it does not set the spacing, and you can see here there's not enough space to accommodate the blade and the washers if I fully, engage the liner to that feature. And without that hard stop, the parallelity between the two liners is not assured, which can actually affect deployment function of the knife. Here's what I would recommend. From this level, raise it to the level of the thickness of the liner. Then you will have a locked distance here, and the pivot will become self-aligning. So you will be able to set the proper distance between the two scales, and you would lose a little bit of adjustability. You don't have to, you can leave maybe 2 thousandths of play there. Then you will have plenty of adjustability to last you a lifetime of the knife. You can actually see how when the pivot is adjusted to where there's absolutely no play, you can see that on this side the washer made a completely circular mark. So the pressure on the washer was even throughout the entire circumference. But here you can clearly see that toward the front, toward the blade, the washer was compressed differently than toward the tail. And it does cause a tiny little hang up when you run the knife. Totally preventable and no extra cost. And so for the knife that flies open like this, I was expecting a little bit better close-up function, especially since they put this little piece of paraphernalia into their box. Now, there's another point that a very famous reviewer made who hates lanyard holes for some reason. I don't know why he is so set against lanyard holes. Folks at TRM, if you're listening, in my daytime job, I work in the office with a lot of military personnel, active duty military personnel, and they all love their lanyards. I have yet to meet a serviceman who has a knife without some kind of lanyard attached to their knife. But this certain big reviewer was incorrect. There is a way to attach a lanyard, and I will demonstrate it in a minute when I reassemble the knife. Before that, though, let's do the test that I bet you are eagerly waiting for. Rockwell Hardness Test. For MagnaCut, hitting the right hardness is critical to maintain that balance of toughness, edge retention, and corrosion resistance. And the hardness where MagnaCut shines is between 62.5 and 64 Rockwell. Let's see if reality corresponds to advertisement. What I started doing is it helps me, it doesn't change the test results. I noticed some of the blades are not 100% flat. After heat treat, there's a settlement in a large flat area, so they become concave. And so that causes me to keep fighting to find a flat spot. A very experienced knife reviewer and a machinist by trade advised me to do this. Put a gelatinous liquid under the blade. Remember, all liquids are incompressible, so you basically taking up that empty space, that hollow space, and that allows you to test the knife as if it was one solid piece of metal. I think turning the machine on and showing it to you would be prudent. Sorry, should have been better prepared. Let's clear the memory here. Set it to HRC. If you watch my channel, I just got done testing 9 prominent manufacturers' MagnaCut steel, and they were all over the place. Okay. See, it's telling me to strike elsewhere. Ooh. Interesting. $61.5. 61.8, really, if you add my calibration error. I'll explain calibration in a second. What I asked Hillary was if they do heat treat in the house, and they are not. They are sending these for heat treat at various shops in the area, depending on how busy the shops are. And they specify 62 to 63 Rockville, but obviously the heat treat shop will not test every blade individually, and there were no markings on this blade that would indicate that the Rockville hardness test was done. Anything above 61.5 is not bad, but it could be better and more precisely heat treated. The inventor of MagnaCut, Dr. Laren Thomas, states in his articles and videos that to reach 64 plus 65 Rockville hardness, the heat treater must do cryogenic treatment after the austenitizing. And cryogenic chambers are very expensive to operate, and they're much smaller than a heat treat furnace, which means some of the blades would have to sit and wait their turn, which means logistical nightmare for the heat treater. It would be very, very expensive. We definitely wouldn't be buying this knife for under $600-700. Now, because it's a small manufacturer and I don't want any sort of future debate how I, try to detriment a fledgling American company. I love these tests and I love American companies, so I wouldn't do it. So I'm going to run the same test on my block. The block is calibrated at the factory to a nominal value of 58.7 Rockville, right there. And as you can see, it doesn't give this every time. So 58.6. If I do it 3 more times, it'll give me slightly different results. But all in all, I am minus 0.1 to minus 0.3. So when you saw the result, it was 61.5 plus, or so somewhere between 61.6 and 61.8. How's that? Whew, that was hard. Now, so that you know my tester doesn't produce BS results, here's the Hogue Mysto, which I tested a few days ago without the gel under it. And now I'm very curious, eager to find out if the test with the gel will give me the same result as without. So that you know that this is not a, look at that. Yeah. Tells me, nope, strange spot, change it. How about that? Don't look at individual, I mean, it's hard to help yourself to not go like, yay! But then the next one will be, woo! You got to go through all 5. Let's see. 63.6. Last time I measured it without the gel in my previous video, and I got 63.8. So we're right there. So as you can see, this proves 2 things. This tester is properly set up and it's not sort of BSing us about the hardness of the atoms or TRM's knife. And the presence of gel doesn't change the hardness or measured hardness of the blade.
So here is the scale on this atom titanium MagnaCut. Anyway, so right here, this is an in between the diamonds path, and those little striations that have sort of circular nature. Those are the tool marks from the tiny little mill cutter that came in and was spinning and going through, and just the tiniest vibration in the entire machine causes these patterns. And as the tool wears out, it also starts becoming more and more pronounced. And looking at the sides, this is the tip of the diamond right here. Look at that. They had multiple. I'm trying to see how they did this. Was it a wedged shape milling tool, or did they come in and do sort of like a 3D printing in the reverse, kind of tiny little passes?
Installing the lanyard on this knife was pretty straightforward because I don't know, by design or by accident, they shaped their spacers like spools, very similar to Chris Reeve, what they did on Inkosi. And on the Inkosi, uh, they relying on the space between the edge and the spool here, on the spacer, to not cut the lanyard. I removed it just to show you in this video how similar they are. And here you can see the other two spools there. All three are identical spacer spools. And there's also a ton of space between the blade and the lanyard, so I can move the lanyard. It does not interfere with the blade, doesn't interfere with any kind of functionality. It doesn't get in the way of anything. It's very convenient for a deep pocket carry knife to extract it out of the pocket in a hurry. I'm not a full-time YouTuber. I don't wear sweatpants or sweatshorts ever at all. So maybe these don't work with sweatpants. I don't know. If you have thoughts about lanyards, one way or the other, write a comment and explain your position. I would be really interested to see where the community is at on these.